Yes. Do you see the Desmos? Do you see? Or no?
Yes.
Okay. Okay. Slow down. Look. First of all, the typical classical exponential function. The graph look like that. Okay, I plot a lot of points, but not necessarily 3 points is enough. The most important points are, for example, the universal point is 0,1, so any exponential graph, regardless the base, you get 2, 3, 4, 5, passing through the point 0,1. Those are two important points, so 3 in total is 1,2 because the base is 2, see the base is 3, is 1,3. And the other is -1 and the reciprocal of 2 is 1/2. 3 point, bam, bam, bam. You are doing the best. Okay, so you want to do more, I put 2,4 and so on. I put -2,1/4. And don't forget, important, the horizontal asymptote que any exponential function has, que is at y equals 0. In this case, because we are discussing the exponential basic without transformation now. Okay, no vertical shift, no horizontal shift, no stretch and compressor, no, basic, natural, like original. Okay, now everyone follow me? It's okay, it's easy, clear?
Yes.
Okay. Who say yes? What's your name, Mister?
Michael?
Marco. Okay. Now the second is the same exponential, but intentionally I change the base to the 1/2. Look, bang. Then is decreasing. Okay, we have two exponential. This one is increasing when the base is greater than 1, and when the base is less than 1 is decreasing. Okay, entonces similar. It's similar. You passing through the point 0,1, you see the family completely passing through this famous point, and this is completely reciprocal. It's in -1 is 2 and in +1 is 1/2. Clear? Then I want to complicate a little bit. Okay, how? Well, this example 3 is wow. Is y equal to raised to the no x is x plus 1 minus 4. Entonces I see transformations. What transformation you can see? You remember the transformation, vertical shift, horizontal shift, reflection, stretching, compressing, vertical and horizontal. In this case, what is the transformation that you can see? Let me come back to the whiteboard. You thinking, and you help me to understand this new problem. Look at that. Now let me share the whiteboard because I want to do some computation on the whiteboard. Do you see the whiteboard now? I suppose that yes, right? So basically,
Yes.
the graph I want to analyze is the graph corresponding with the function y equal to the exponent is x plus 1 minus 4. Okay, and I compare versus the basic function gets 2x. Okay, I am familiar, super familiar, right? So what kind of transformation you see in this new expression? Well, you see that somebody adding 1 and the exponent, and instead of x is x plus 1 and minus 4. So basically, the transformation is suppose that this is my original function f of x. The thing that we are doing is adding 1 in the argument, x plus 1, right? This is this. And after subtracting 4. Okay, my question was, what is the name of this transformation? And what is the name of this transformation? Who help me? Who's there to answer the question? Nobody know? Nobody remember? And you expect to pass this class you don't remember transformations? Come on, opinion.
I can help.
I can't. Con T.
I can help. The -4 on the right side is to the left, I believe, and f of x plus 1 is downward transformation.
But in what direction is moving? When the x plus 1 is horizontal shift or vertical shift?
It's a vertical shift.
Plus 1. Plus 1, you say?
Downward shift, my bad. Downward shift.
All right, plus 1. In what direction is moving? Left, right, up, down. Elsa, you don't know?
To the left.
To the left. To the left, 1 unit. Okay, when you adding or subtracting inside the parentheses is horizontal shift. And horizontal shift, we have 2 possibilities only. Is left or right. So plus 1 is, I repeat, listen, horizontal shift, 1 unit to the left, because it's plus. And -4 is obvious que es vertical shift, 4 unit down. So this is the transformation that I wanted. Clear, mister?
Yeah.
No, I appreciate so much participation, but okay, you need, okay, now curiosity now. I want to, do you see whiteboard, right? Let's try to find, for example, the y-intercept is important point and x-intercept. The formula for finding, Elsa, do you see the whiteboard now or no?
Yes.
Okay. Es evaluate the function at 0, no? It's equivalent to say 2, 0 plus 1, -4. 0 plus 1 is 1, 2 to the 1 power is 2, and 2 minus 4 is -2. Therefore, the famous point is the point 0, -2. And this is the y-intercept. Cool? In order to find the x-intercept, the formula is f of x equals 0. Therefore, as you put a y equals 0, so you have equation like that, 2x plus 1 minus 4 equals 0. And we convert immediately an exponential equation. Yeah, I know very well that 4 is 2 to the second power. So in that moment, we have 2 exponential and the base is the same. The idea is that the exponent is the same. Therefore, x is equal to minus 1, que 1. Now the point is a point 1, 0. You see now in Desmos this idea. Do you understand this or no?
Yes.
Okay.
Yeah.
Okay. Before to switch into Desmos, this is example 3, no? Example 3 in Desmos. Complementary 3, I call CO3. It doesn't matter. Let's solve in two more. And after we see completely in Desmos, no? Because when I transfer to Desmos, I come back to the whiteboard now. Suppose example 4. Example 4 is y equal, now the base is 1/2 raised to the x plus 4 minus 4. We compare this example and this example. Okay, in this case the base is 2. In this case the base is 1/2. So I need to know okay, when the base is greater than 1, at least the appearance of the exponential look like that. Ooh. However, in this case, look like that. Ooh. Well, this is not good sketch, like that. Asymptotically here, asymptotical here. Now this is obvious that this is increasing, o sea, it's growth exponential, and this is decay. Okay, this is important detail. Now, I dedicate to see now, what about a transformation? Because the base C in that case is y equal 1/2 raised to the x. It's the base C. I showed you a few minutes ago. Now I see transformation. Who helped me with the transformation? No, Elsa. Another student. What transformation you see in between this and this? In what direction?
Now,
Say again?
the -4 is like 4 units down.
Very good shift. Very good shift down. Cool.
And then the x times plus 4 that's to the left.
Horizontal shift to the left. Very well, very well, very well. Likewise, you determine the specific important point, que es y and z and x and z. To find the y and z, remember you are doing x equals 0. Es a formula, ¿no? Entonces es equivalent to say 1/2 raised to the 0 plus 4 minus 4. And we compute that value. 0 plus 4 is 4, and 1/2 to the 4 is 1/16, no? Because it's 1 raised to the 4 power, and 2 raised to the 4 power is 16 minus 4. And you compute that. It's easy, because you find the LCD, which is 16. It's a 1 minus 64. Where come from 64? It's a multiplication 16 times 4, no? It's 63. So it's minus 63 over 16, que es, a negative number fraction. Okay, the point is the point, 0, comma, minus 63 over 16. You see in this one now. And the x in z is f of x equals 0. In other words, you take this, you put it together, 1/2 raised to the x plus 4 minus 4 equals 0. Okay. Now, solving this exponential equation, we have 1/2 raised to the x plus 4 equal 4, but I know that 4 is 2 to the second power. Okay, I know that 4 is 2 to the second power, and I know that 1/2 is 2 to the -1 exponent reciprocal. Now you replace 2 to the -1 raised to the x plus 4 is equal to 2 to the second power. Therefore, multiplication is 2 to the minus x minus 4 is equal to 2 to the second. Wow, same base to exponential. Therefore, the base is the same. Now the conclusion is minus x plus minus 4 is equal to minus x is equal to plus 4 is 6. Therefore, x alone after the multiplication or division by -1 both sides is -6. And the point is -6, comma 0 is the x in z. Cool.
Yes.
Everyone follow me? No question. Do you understand every concept behind this? So the
Yes.
central idea now is exponential. It's a new function that we study. And we apply, by the way, some transformation because I want to reinforce this idea, no? Okay, example 4, example 5, is the last one so far, is y equal minus x to the -3. Okay, it's exponential also, no? Belong to the family of the y equal 3 to the x, no? Without, this is the basic, without transformation. but I did something. I have two negative inside the new one, no? Entonces this, when you see negative, what is that? What is that? What is that? What is when you put a negative, when you replace? Look, this is my function. This is my original function. However, I am doing something. I am doing this negative inside the argument get this. I am doing another negative outside get this. Now, I suppose that you remember that when you put a negative, when you replace x for negative x and negative number, negative sign is reflection, no? Do you remember or you don't remember?
Yes.
Entonces you have two reflection, ¿no? In this problem. O sea, the original exponential, the base is 3, look like that. Oh, yes or no? However, we have two kinds of reflection. We have reflection. This is reflection about this negative. A reflection about the y-axis. So now my exponential look like that. Okay, this is 3 to the minus x. This is 3 to the x without transformation. And the other sign is negative. It's another reflection, but a reflection. This was reflection about the y, and now this is a reflection about the origin. Can look like that. This is minus 3 to the minus x. Okay, double reflection. Double reflection. Do you understand very well this or no? Confusing, eh?
It's a bit confusing, but I'm getting it. Thanks to you.
Say again.
It's a little bit confusing, but I'm understanding it.
What part is confusing? I don't understand what part is confusing. You help me to understand what part is confusing. But you understand now, you say. Okay?
Yeah. I thought it was a bit confusing, but now that you explain it like this, I understand it better.
Okay. Well, so now let's compute in that case exactly the same. Y intersect, X intersect. Y intersect, X intersect is important point always in the graph of any functions. So Y intersect is when the X is 0. Another way to see the same idea is you evaluate in 0. So basically is minus 3 minus 0. Ooh, but minus 0 have no sense. Minus 0 is 0 because 0 have no sign. And any expression raised to the 0 power is 1. No? But don't forget you have a negative 1. So it's not the same. Negative 3 raised to the 0, que obviously is 1. And minus 3 raised to the 0, you are doing according to the order of operation, you are doing the exponential first, so it's negative 1, because 3 to the 0 is 1, so any number or any expression raised to the 0 power is equal to 1. No? Entonces the point is 0 comma negative 1. Okay, cool. Now okay, there you go. Okay. Now X intersect is different. Is you evaluate the function as 0. Okay, now it's minus 3 raised to the minus x equals 0. Well. You divide by negative 1 both sides. Entonces es equivalent to say 3 to the minus x equals 0. 0 have no sign, you know. Now, you remember that any exponential, in that case, the exponential, this exponential is like that. Never touch the x-axis. And never y is 0. It's asymptotical. So when you see one equation that have equals 0 or negative number, this is a contradiction. No solution. Therefore, the conclusion is we have no x in a set. No. Y-intercept, yes. X-intercept, no. Okay. Okay. So now to verification everything, let's move on to Desmos and you see one by one example 3, 4, 5, no? Graphically. Desmos. Okay. Let me switching to Desmos. Okay. I suppose que you copy in your notebook the value, no? You copy. Do you see Desmos? Do you
Yes.
see?
Yes.
Okay. Okay, now the graph is like that. Boom. We confusing, very confusing. Okay. Focus. Look, this is my graphic. It corresponds with the new exponential. In this case, we have two transformations. So we take the original 2 to the x. We're moving. One unit to the left because it's +1, and subtract the 4 as you're moving 4 units down. It's a very good shift. Now, when you're moving 4 units down, you're moving the exponential, including its asymptote. It's very asymptote. Normally, the vertical axis is located at the y equals 0, so on the x-axis. But in this case, no. In this case, it's located on the horizontal line, y -4. Do you see this idea? And the famous y-intercept is 0,2, 0,2, sorry, and 1,0, exactly the same we computed before. Cool? Any question? What part you don't understand? I need to understand your situation, no? What part you don't understand? Everything is okay or no?
If we have to find the
I don't
y-intercept, is f
Uh-huh.
of x always is x always going to be 0 when we have to find the y-intercept of the function?
Exactly. This is the formula, mister. When you want to find the x-intercept, you enforce the situation and declare x equals 0, and you find the y associated with that. We can condense in this information in function notation. No? This is the advantage of the function notation. Can you evaluate f parenthesis 0 in the argument, and you find the value que corresponde with the y. Make sense?
Yeah, it makes sense.
Cool. Let's move on to the second example. This is number 3, now number 4. Number 4 is the only new situation in number 4 is que the base is 1/2. And when I know that when the base is 1/2, the exponential is decay, so it's decreasing. Okay, we have two kinds, only two, 50-50. Growth exponential or decay exponential. In this case, it's obvious it's decay because the base is 1/2, is less than 1. Of course, we have two transformations. The transformation is 4 units, so horizontal shift, 4 units to the left, and by coincidence, vertical shift 4 units down. Therefore, again, one more time, the horizontal asymptote now is at -4. Look. And the famous point we computed before in the whiteboard was the x-intercept and the y-intercept. The y-intercept was the point 0, -63/16. Okay, and the x-intercept is the point -6, 0. Do you see that?
Yes.
Okay. Any question? So I complicate a little bit. So not only the basic transformation, horizontal shift, vertical shift, sino the extra complication in the exponential is Okay, you have two kinds of the exponential. You have the growth exponential and decay exponential, or exponential decay. Doesn't matter. Now the question 5 is the double reflection, no? And double reflection is something like that. Double reflection. So we are doing one reflection about the y-axis, and another reflection about the origin is very similar to the x axis. And we determine we have only one intersect the y intersect is 0, -1, and we have no intersect in the y-axis. And the reason is clear, because it's asymptotically. You approach it, close, but never touch, because it's asymptotic. Cool? Cool?
Yes.
We come back now to the whiteboard. Let me try. Whiteboard. Do you see the whiteboard?
Yes.
Okay, so now I want to explain. Remember, I say everyone bring calculator today, yes or no?
Yes.
So now in our calculator, we have the standard logarithmic function. Okay, what is that? Standard, I suppose I forgot. Standard, this is M. Standard logarithmic function. So now, we studied so far intuitive idea for the logarithm, ¿no? Entonces, okay. Entonces, el logaritmo, it doesn't matter, the base 3, the base 4, the base, no. In the calculator, we have two keys for the logarithm. One is called log standard, and another is lm. Okay, what is that? This is the common logarithmic. And the common logarithm, the base is 10. This is a standard we have in any calculator in the world, base 10. And the symbolic way to indicate is log. And no specification, any number here is missing this number. You put log of, for example, log of 3. Normally we put a parenthesis, you know? So people omit the parenthesis to write too fast. Pero in my opinion, yes, because it's a function notation, no? The function notation, you know, it's a name of the function, parenthesis x. You write like that without parenthesis. Nobody understands very well this. But in the logarithmic, I don't know. The people write too fast, log3, everyone understands the word. Entonces, now, the most important is no the parenthesis. The most important is the missing number. Wow, si it's missing, default, you need to know que es common logarithm and base 10. Cool? And this common logarithm is applied in science, in physics, in chemistry, because it's easy to manipulate. Okay? However, in calculus, you apply a natural logarithmic. Logarithms. Okay, is natural logarithm of the base is the famous number e we studied last class. E is approximately, you know, it's irrational, infinity decimal, approximately 2.71 828, and you know, infinity non-repeated decimal, it's irrational. Okay, it's easy, you put in any calculator, So the same key in the calculator, we have the associate. Look, this is the same key. Same key. Can you select same key here and here? Can you select normally in any calculator using the second function? Second function, you press second and you switch into this in the same key. And this is the exponential, this inverse function associated with the corresponding logarithm. This is e to the x, and this is 10 to the x. This is exponential. It's the opposite, the inverse function for the logarithm and the corresponding. For example, in the calculator I have in my hand now, I have two keys, yeah, log and ln. However, see, I want to select the exponential. Well, you have another key in different color. In my calculator, blue. So you press blue log. So now we are working with the exponential. So blue. This is blue in my calculator. In other calculator is yellow, whatever. You select this. Okay, and so you press blue, you select the exponential. Okay, very important. I promise that today we practice with the calculator to say now be ready your calculator. But not exactly now, because before to do anything we need to well, I forgot to say something important. The notation for the natural logarithm is ln. When you see ln of one number 4, that means que es log base e of 4. But nobody in the world write like that. Use ln. So we have, in general, to understand the notation, it's important. So you have non-standard base. Non-standard base logarithmic. Okay. You write like that, logarithm base 4 of 28. Okay. However, the majority of calculators have no non-standard base. The majority of calculators have the standard base. So you can compute logarithm like that of 28 or natural logarithm of 28. If we study now the relationship in between this and this. Suppose que in one problem you need to compute logarithm base 4. So there are calculators that, yes, have possibility to introduce any base non-standard, but 99% of the calculators have no base non-standard. So we use a standard, this or this, and they are a formula to compute the logarithm of non-standard. Okay, no more blah, 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 blah. Let me erase this. I want to explain the 8 complementary properties for the logarithm. It's another new property. It's amazing, guys. Amazing. Look, this is the property. Property of logarithmic. You remember that we have pending one equation that we cannot solve. It's the equation 2 to the x equal 3. It's pending. No, because I have no mathematical tools to face this equation. That is the reason that we deviate the thing to the logarithmic function. Now, this is pending. We solve it in a few minutes. Now, the most important, number 1 property is logarithmic of the any base of 1 is equals 0. You need to remember this. Standard, non-standard, you put in the calculator if you want, log1, que I suppose que es common, es 0. You put ln of 1, es obvio que es 0. log base 2, for example, of 1, is 0. When the number inside the argument is 1, you need to know que es 0, right? Are you clear?
Yes. Yes.
Cool. See, any question, you let me know. I prove one more time. Number 2, property is log of the any base and a is 1. Let me try to understand. Let me try to interpretation this. When the number inside the argument is equal to the base, the answer is always 1. For example, logaritmo base 2 of 2 es obvio que es 1. Logaritmo common of 10 es obvio que es 1 because the base default here is 10. ln of e es obvio que es 1. Do you understand?
Yes. Yes.
This is property number 2, guys. E and the solution of the problem. I frequently say, I apply property number 2. I apply property number 1. I apply property number 5. Okay. Property number 3. On number 3, take advantage the relationship between logarithms. So you have logarithm of the any base, standard or non-standard, of the corresponding exponential, and you need to know that the exponential function and logarithm function are inverse function. Therefore, when you put together like a composition, undoes each other, and the answer is identity. It's the same number. Okay. This is obvious, right? This is, remember when you study the composition, one function is inverse, the answer is identity in any direction. But in this particular example, we are talking about exponential logarithm que satisfy this perfect condition. No? So let's do it. For example, so you have log, no specification, the base is base 10. Of the 10 to the x, es obvio que es x. Ln e to the x, wow, es obvio que es x, right? This is using a standard. Bueno, y in the opposite direction, professor, it's the same. This is property number 4. The property number 4 says you apply exponential first and logarithm secondly, the answer is x. By the same reason, it's magically, it's like this and this cancel out. Boom, boom. Logarithm and exponential undoes each other, and logarithm and exponential undoes each other. Do you follow me?
Yes.
Okay, property 1, property 2, property 3, property 4. Guys, I promise we are using this property every day so far. Property 5, 6, and 7, in my opinion, is the most important property. Okay, what is that? I want to explain in detail. Logarithm of the any arbitrary base of the multiplication to expression I want to call m and n. As you expand, if you need or you want, into logarithm of the m plus logarithm a of m. Entonces now we are using that property in both directions, in this direction or in this direction. What is the application? Suppose that you have equation, and this equation contains 5 logarithms. This is crazy. But we can condensing. So in that direction, you condensing, condensing 5, in this case 2, no? But in general, it's any number of logarithm condensed in only one. If you are doing the multiplication. So in other words, one example, suppose a logarithm of 6 is equal to logarithm of 3 plus logarithm of 2. because you have two logarithm modules. I put in a calculator 2 times. This a calculator, this a calculator. No, you condense in only one, que 6, and you compute this in the calculator 1 time. Or you can condensing. It's a very, very popular, this direction. Or expand, in which is very convenient, separate in several logarithms. Doesn't matter. That depending of you, the necessity you have, and the problem. Condensing or expand. How frequently we're doing this. Similar property number 6 in the division. Suppose inside the argument we have division m divided by m. O sea, it's division two expression. Entonces, you separate numerator positive and denominator negative. Don't worry, I bring a lot of examples to illustrate this property right now. Suppose que, professor, well, so you have combination. You have, for example, multiplication and division. Well, it's similar. It's the only thing you need to know is when this multiplication is plus and when this division is minus. So you apply property 5 and 6 together, no? For combining. And this is the super important property. Logarithm of base A of the one expression I want to call m, but contain one exponent I want to call r. Oh, this is super, 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 in my opinion, important property. Because the properties say that this r gets exponent go outside like a multiplier. Okay, this is magic. Because this exponent fly outside and multiply by the logarithm, right? And this is magic. Why? Because suppose that you have a exponential equation, no? And now when you apply the property number 7, can you apply logarithm both sides, then you convert to the linear equation, no exponential equation anymore. Let me see. Suppose the famous problem that we have pending, 2 to the x equal 3. This problem is obvious that we cannot solve it using the traditional way. CF4, yes. CF4, yeah. Pretty easy. Because I know it's 2 to the second power. Therefore, x is 2. Okay, cool. But CF3, CF5, CF7, it's impossible. Solving this exponential equation using the traditional way. Now, well, professor, entonces now what should I do? When you apply logarithm on both sides, you apply logarithm. What kind? Of course, you apply standard. Because this problem, for sure, I guarantee you, that the solution is irrational and the solution contains infinity decimal non-repeated places. Now you can find not the exact solution, you can find the approximate solution. When you apply logarithm on both sides. And this is perfectly licit because logarithm is 1 to 1. So now stay the equal sign. Now you apply the property number 7 that we are studying now, and magically happen, ooh, this exponent fly is put outside. Now x natural logarithm of 2 is equal to natural logarithm of 3. Are we finished? No. You divide by a natural logarithm of 2 both sides, because my goal is isolate x, and x alone is natural logarithm of 3 divided by natural logarithm of 2. Okay, and this is this is the exact solution, exact answer. Is very, very weird, but it's good. However, I want to show you in detail how, and you help me, how we compute in the calculator this. Okay, so in the calculator, we have no exact answer, we have approximate answer. But no, after we practice a lot of this. Okay, but the important thing I want to emphasize is the application for the property number 6. In my opinion, is magic. Okay, in mathematics, there are some magic thing. It's unbelievable how we convert this original exponential equation in one linear equation, because this is linear. Look, linear like that. 2x equal 3. How you solve that? Divided by 2. Boom, linear. 3/2. In this case, it's no 2 and 3. Is x logarithm 2 equal logarithm 3. It's not 2 and 3, it's logarithm. Entonces, some students confusing with this. But this is just a number, and this is another number. And you pass to the other side, divided by that, ln of 3 divided by ln of 2. And this number is weird, I know, I understand. However, it's doable, you using the calculator. Okay, so the magic thing is conversion from this equation, que es exponencial, to this equation, que es linear. Do you follow me? Confusing?
No.
No. Okay, cool. Now the property number 8 is super important. Super important. You say, Professor, everything is important for you, no? Well, and depending, no? The scenario, depending the example, no? But this is super important. Why is super important? Because receive a specific name. It's important because have a specific name. Okay, the name of this is change of base formula. And let me try to write. Yeah, explain the idea behind this. You have logarithm of the any base I want to call a, or the one expression I want to call x. Expression or number, 2, 20, 40. And just so you compute like a division, another base of the same argument divided by logarithm of the same BB of A. This is a formula. Let me try to explain the idea. Let me try to put example. The application of the formula. Suppose I want to compute this famous logarithm that we compute the last class using intuition. Logarithm base 3 of 81. Do you remember that? Do you remember that or not? Guy, answer me.
Yes.
What is the answer of this logarithm?
Form.
F4. Very well, F4. Let me try. Okay. Listen to me. So far, from today, we have no excuse to don't know any value of the any logarithm, because I want to explain two different ways. By hand, not always is possible, and using calculator, using the chain of base formula. Okay. By hand, I have no idea. Elsa, yes. Elsa has idea. The majority of students stay quiet. I don't know why. You convert to exponential. And when you convert to exponential, remember the organization that you need to keep in mind is you put a base. The base is so big as 3. You put the big 3. So this is small 3. I put big because now at the base in the exponential statement. The exponent is exactly I don't know. It's exactly I am looking for is equal 81. Yeah, I try to express 81 using like a power of 3 is 3 to the 4th power. Because 3 times 3 times 3 times 3 is 81. Now we have in that moment to exponential, the base is the same, the conclusion is x equals 4. I suppose you remember very well this, yes or no? Or not necessarily doing, intuition, F4, because what is the exponent necessary to raise 3 in order to get 81? F4, that's it, end the story. However, suppose you don't remember this, okay, but you have calculated. So we are doing this job, we calculate. This is by hand, and by calculator now. Using that formula. Using that formula. Okay, by the way, the name is chain of base formula. So I have in the original problem non-standard base, que 3. However, in my own calculator, we have 2 different of standard, common and natural. Suppose I make a decision to apply common. You put 81 divided by log of 3. Okay, let me try to compare this statement and this statement. A is, let me using this. A is the given non-standard base, in our example is 3. However, I cannot. They are not, the majority of calculators no support base 3. However, I change to the base B. B is the new base. Okay, in this example, I select 10. That's the reason. And X is 81 in our example, and A is 3 in our example. Do you follow me? Do you follow me? Now,
Yes.
calculator. I put in the calculator. I put in the calculator. I put in the calculator. Of course, I have virtual calculator. I want to show you right now. Virtual calculator. I want to show you right now. Share calculator. Do you see my calculator? Or not yet?
Not yet.
Not yet. Now?
Yeah.
Yeah, now
Yeah.
we can see.
You see now? Okay.
Yes.
I see. Maybe you see only the calculator, no? I see my whiteboard. Yeah, I see the. So any calculator is different. You need to take to your own calculator. Of course, this is virtual. I have another here in my desk, physical. I have in my hand right now. But it's okay. So I try to find in the functions here. Oh, logarithm. We have two kinds. Look, ln and log. However, in the board, I select log. After, let's see what happens when I select ln. You see, log of what? Of 81. Entonces now, in order to doesn't switch into the keyboard, I type 81 in my keyboard. 81. Oh, you see, this is the answer. This is the answer que normally is irrational number. Now division. And keyboard, I type in division. I type in again logarithm. Base 3. Boom. And look at the answer, guys. Look at the answer. The answer is 4. Do you see? Wow. Amazing. Okay. And what do you think see I try to using ln? I don't know. ln of 81. Of course, close the parentheses. Okay, to indicate the argument. Now division, ln again of 3. Boom, same answer. So it doesn't matter what kind of logarithm you select, common or natural. So the thing that we are doing is computing using the calculator one logarithm of the non-standard base, 2 standard base. It would be fantastic if you try to do right now in your own calculator. And you let me know if you get the same answer or not.
We got the same answer.
Yes.
No?
Yes.
Okay, beautiful. Beautiful. Okay, I go to the whiteboard to illustrate. Do you see whiteboard?
Yes. Yes.
Okay. To illustrate que es possible computer using common or natural. And the answer was the same, 4. Entonces, so far, when I say, what is the logarithm of something? What is the logarithm, for example, what is the, let's see another example. And you help me by hand and calculator. Suppose compute logarithm of base 2 or 32. Okay. Well, it's easy because you put in your own calculator como logarithm of 32 divided by logarithm of 2. And let me know what is the answer, please.
5.
5.
5. F5. Yes or no? What logarithm are you using, common or natural?
Common.
Common, okay. At the beginning, the student prefer common. The reason is because belief is more clear because it's the same letter, L or G. And somebody you scared a little bit, que es el N. I don't understand very well. Image. What the main image? 32 divided by ln2, no? And the answer is 5, no? And the answer is 5. And by hand is, suppose que in the jungle without calculator. Bueno, in the jungle we don't need logarithm, you need food. But it's okay. Suppose x, and you convert to exponential to understand much better. Entonces now the base is 2, the exponent is x, the answer is 32. But 32 I investigate que es 2 to the 5th power, no? You multiply 5 times 2, get 32, therefore 2 exponential, same value, therefore the solution is 5. But in the majority of the scenarios, we have no. The majority of the scenario is doing using calculator. Because in this elementary example, okay, this discussing now, is a nice number and we get natural number, or maybe, but in the majority of the scenario, the answer of our problem is irrational and obtained by the division to logarithm. Okay. By curiosity, we come back again to the famous equation that we have pending. Remember, 2 to the x equal 3. I want to repeat again this process. You apply logarithm both sides. You apply logarithm both sides. It's the only possibility. Okay, entonces now in the future, you say, bueno, this exponential equation, guys, you can solve it by the traditional way, or you apply logarithm on both sides. Oh, no, you can apply logarithm on both sides. What kind? Standard, of course, because we ending in calculator. Before, I apply ln. Now I apply log. Either way, the answer doesn't change. I illustrate. Now you apply the property number 7, que es magic. Allow me, this exponent go to the front. Now divide both sides by log of 2, and the answer is log of 3 divided by log of 2. And finish. Finish if the question say find exact solution. But the majority of problem, no. The majority of problem, you need to find the approximate answer. An approximate answer, they say you using 3 decimal place, 4 decimal place, suppose 4 decimal place, and you round off this answer, right? Using the rule, okay, you know very well to do that. Let's do it. Try to help me in your own calculator. Try to help me in your own calculator. You put in your own calculator right now. LOG of 3, division, LOG of 2. Okay, typical mistake. The students say LOG of 3, division, no. You close the parenthesis to indicate que the first logarithm ending the argument divided by in the calculator LOG of 2. Entonces, what is the answer? All right, let me try to do it in my own calculator. You are doing in your own calculator. Come on, don't be lazy. LOG of 3 divided by LOG of 2. You get the answer or no?
Yes,
I got 1.58.
1.58. One more digit.
Or if we like to round it, it would be 5.
You copy the thing that you have in your display. Okay, by the way, not necessarily the same in any calculator because any calculator have particular specific approximation. No? 51. Entonces, my calculator truncate like that. Boom. Don't expect that any answer is the same in any calculator. However, in the test, I don't remember which specification that we need 4 decimal place. 1, 2, 3, and 4. And the rule of random is the next digit is 6, que es greater or equal 5, you adding 1. Entonces es 1.5850. Es the answer. Do you follow me?
Yes.
Okay. This is the thing we're doing so far. Calculator, you know, apply the property. You isolate the x. And normally never ask me exact solution because I don't have idea what is this number. Say 20, say 40. No, I am lost. However, I know get 1.58, 50. Okay, let's practice because in the Alex homework, in the Alex, we apply the property. We are doing quickly some example of the application of the property. Suppose. Look, quickly. Suppose I have 4 times logarithm base 2 of x minus logarithm base 2 of y. And the question say, express as a single, o sea, only one, logarithmic. Express as only single. We have several logarithms, you condensing in only one. Bueno, entonces si wow, we have 2 logarithms, but one logarithm have a factor here, another no. Another important thing I need to see is subtraction. And subtraction is related immediately using the property number 6. So basically you apply property number 6 and property number 7. Property number 7 is this factor. I move, but move in opposite direction, like exponent. And you condensing in only one logarithm. The base must be the same. You have base 2 here and you have base 3 here. No, we cannot apply the property. Let's see what's going on in this moment, not now. Entonces now I apply property number 7 in the first part. Yeah, I apply property number 6 in the second part. And then we have in the argument of this x to the 4th power and y. Boom, that's it. Do you follow me?
Yes.
Yes.
Okay. One more example.
Professor.
Uh-huh.
Sorry for interrupting you. I have a question. I have a English final exam, and I have to drive to school, so I wanted to know if I can get permission to leave a little bit earlier today.
Okay, no problem.
Thank you.
Example 1, example 2. What's your name, miss? She's left. Okay, suppose this. Suppose 1/2 logarithm of base 3 of x minus 4 minus logarithm of base 3 of x. You know that I always be careful and put the parenthesis to enclose the argument of the logarithm. Some book, some people do not that. But this is confusing. Okay, this is similar. It's again division because it's minus, but the factor is now 1/2. So basically, when you condensing this logarithm of base 3 of x minus 4 raised to the 1/2 and x, and this is totally inside the logarithm. Okay, so now, and Alex, to confuse the student, they don't remember very well the conversion between fraction, exponent, and radical, write like that. Square root x minus 4 or x inside the argument. It's equivalent. Exponent 1/2 and radical notation. So let's do it now backward. And one more example of a completely backward, confusing. Suppose we have example 3 in which you are doing completely opposite operation. We have a condensing logarithm, only one, formed by several expressions inside the argument, and you expand. Suppose naturally, LA. Okay. And suppose we have a completed fraction, m to the 5th power, multiplication, m to the 8th power, division, x to the 6th power, times y to the 7th power. And what's my goal? My goal is expand. Of course, expand in several logarithms and express the power as a factor. Okay, and to say we apply in this case, when you expand this, you apply simultaneously property number 5, property number 6, and property number 7. Remember, the property number 5 is when it's multiplication is addition, and the property number 6 is when it's division is subtraction, and the property number 7 is the decay for the factor, the exponent can become like a factor, no? Put in front. Okay, to say it's easy, everything in the top is positive, everything in the bottom is negative, right? So we have 5 ln of m plus 8 ln of m minus 6 ln of x minus 7 ln of y. Do you follow it?
Yes.
Okay, it's the expand. That's it. So we are strong. No more explanation. It's clear for us. Okay, let's move on to the solution. So with the case, you know very well the collection of the complementary property for the logarithm. We will be able to destroy any exponential equation with the same or similar base or no. we apply logarithms. So I bring several examples of the exponential. Suppose this example. Suppose 5. Now.
Professor, I have a question.
Go ahead, go ahead.
When will you post the practice test or review for the exam, the written exam?
Well, I suppose. Okay, let me check it. Remember, I have different subjects. I have different classes, so I don't remember very well. But I suppose que en Alex, let me try to open Alex. Alex, we have time. We have time. Don't worry. We have time. En Alex, I put the due date for the test for
The next Monday, I think. Oh.
Yeah, Monday next week, sir.
No. I changed that. I suppose I changed that. Test for. Oh yes. No. Okay, don't worry too much. Don't worry. So you want I sent today. Today when I send the video, I send both. But the indicator, no. You relax. The indicator we are approached to the test is when you finish the review. I don't send the review. But don't worry. Today. No, now immediately because I need to go to the campus. I have at home. But when I finish this, immediately I need to go to the campus because I have another similar class. Now, when I come back to the campus, it's at 5 p.m. Remember I am doing tutoring after that. Well, entonces now I send, don't worry, I send, yeah, you start working this. No problema, it's no secret, it's no top secret. But the indicator that we are ready is when you finish the review, as always, no? Entonces now I suppose que extending maybe Friday next week. Okay, no Mondays. Monday is too far, too near. Okay, relax. You relax. Everything's gonna be okay for you. So you are doing well, of course. Okay, do you see whiteboard or no?
Yeah.
Okay.
Yes.
Look, the next exponential equation I call complicated. Easy and complicated. Is this. You have to solve for x. And obviously it's exponential equation. Well, what is the step? Step 1 is try to isolate the exponential part. So you try to isolate that part. Therefore, you divide it by 5 both sides. Okay, and never we can get the same base. No, this is impossible. Therefore, you apply logarithm. What kind? Standard or yeah, standard logarithm. What kind? Remember the standard we have log and LA. At the beginning, the student prefer log. I don't know why, because consider that ln is weird. No, it's not weird. It's nice. However, let's solve it by log. No problem. Log of 2 raised to the 3x equal log of a over 5. Okay, you apply now the property 7, and the property 7 allow me magically this exponent fly to the front like a 3x. Log of 2 equal log a over 5. And you don't worry too much for this log of 2 and log a over 5 because this is just a number. And we can compute it with a calculator, of course. Now, finally, So for x, you divide both sides by 3 and log. So we have x is equal log of a over 5 divided by 3 times log of 2. So far, you follow me?
Yes.
This is not exactly the moment to put in the calculator because my strong recommendation is try to optimization the computation, no? Because this tree is, okay, I want to apply one more time the property number 7, but Bauer. What mean Bauer? Okay, this tree you put like exponent, you put log a over 5 divided by log of 2 to the third power. You understand this? And 2 to the third power obviously is 8. And not necessarily right like that, you put 8. And this is the moment to put in the calculator because it's too easy. If you put one logarithm at the top, division, one logarithm at the bottom. Be careful, guys. Be careful because in the display of the calculator, you put log. Automatically, when you type in that function, the display show you one parenthesis, this parenthesis, the first one, and you put a division 5, close the parenthesis to end in the logarithm at the top. Now another division, log, open parenthesis, a, close the parenthesis, and now ready to press enter. You get that? Give me the answer, please. Using 4 decimal place. So approximate answer, day 1. Approximate, the symbol indicate approximate, is, who help me? Come on, everyone working with the calculator. And
0.2260.
Okay, let me copy everything. 0.226. Okay, who? Michael. 0,
2,
2,
3,
3, 9.
968.
Depende of the calculator, no? Michael, that was wrong. Sorry. No, it's okay. My calculator give me one more digit, but it's not important. So the important is 1, 2, 3, and 4. That depending the question, no? The question specification. I need the answer using 4 decimal place. So remember the rule of the round off. Si this digit is less than 5, you omit this. The answer then is approximation 0.2260. Done. Finals. Super clear?
Yes.
Okay. Okay. I want to complicate more this. Suppose this equation. Zero 0.3 raised to the 1 plus x equal 1.7 to x minus 1. Wow, look like horrible. However, it's easy. It's easy. So you realize, number 1, okay, we cannot solve it by the traditional way. No, you apply logarithm of both sides. What kind? Standard, because we ending in calculator. I want to illustrate. Can we apply ln? Why not? What is the discrimination ln? Ln is nice. So you apply ln both sides. Okay, now apply the famous property 7. The exponent go to the front. Okay, just go to the front. See, go to the front is 1 plus x. This is super important, guy. When you see it's a binomial, you put the parentheses. So you have logarithm of 0.3. And 2x minus 1, parenthesis, logarithm natural of 1.7. Everyone follow me so far?
Yes.
Cool. Now, remember what is my goal. My goal is x. It's exactly the same. Let me try. This is a number, and this is a number. And suppose, hypothetical. Of course, no, it's not true. Suppose that we have 1 plus x, and we have 3 here. No logarithm of 0.3. And suppose that you have 2x minus 1, and you have 7. No 1.7, it's 7. How you solve this equation? Why don't you apply this derivative property? And we combine like a term, and you try to move the x in one side. I prefer the left, and the number to the other side, to the right. Exactly the same we are doing in intermediate algebra. No difference. So you don't worry too much for this number, because it looks like we are. What the hell is that? But it's just a number. So you apply distributive property. When you apply distributive property, logarithm, natural logarithm of 0.3 times 1 natural logarithm of 0.3 plus x times natural logarithm of 0.3 again. S equal, in the right hand side we have 2x natural logarithm of 1.7 minus natural logarithm of 1.7. Do you follow me? Do you follow me? Do you understand this? Sound weird? Distribute. Distribute. Because this is just a number. We are number, but it's a number. Yes or no?
Yes.
Cool. Okay, now what is my goal? My goal is x. I need to do something in order to isolate this guy and this guy. Because I propose moving to the same side. Either way. Suppose I make a decision. Not necessarily doing it in my way. You using your own algebra. Suppose you say, well, no. This stay here. Okay, I move this to the other side because I want to put together the guy que contain x minus x natural logarithm of 0.3. And the other side I move plus natural logarithm of 1.7. Do you understand this idea?
Yes.
Now I go to the next step. Well, bring down this for a moment, temporary. Here I factor out x because we see x and x. So we have inside the parentheses 2 ln 1.7 minus ln 0.3. Okay. Finally, divide both sides by this expression. Wow, both sides by this expression. I don't want to copy. And so we have natural logarithm of 0.3 plus natural logarithm of 1.7 divided by 2 times natural logarithm of 1.7 minus natural logarithm of 0.3 sx. Do you follow me? It's clear or no?
Yes.
And this is ready to put in the calculator? No. The answer is no. You can put in the calculator. See, you are strong to separate parentheses. But no. I don't like this. I like condensing. Everyone doing it that way. You condensing this logarithm and this logarithm together in only one. And using the property phi. Let's say the property phi. When you have two logarithm addition, it's a multiplication. So you put in a calculator multiplication who? Multiplication 0.3 times 1.7 is 0.51. So you condense it in only one logarithm of 0.51. Where come from? 51. 51 was the multiplication 0.3 times 1.7. You condense it in only one logarithm. Cool. And the bottom, similar, but I apply the property number 6 because it's subtraction minus, and property number 7 because we have one extra factor that I convert. That actually is 1.7 squared, this 2 is exponent, divided by 0.3. Of course, I put in a calculator. It's 1.7 squared division 0.3, and this give me, okay, it give me logarithm of 0.51 divided by logarithm of, I compute this in the calculator, give me a weird number, 9.63 repeated, 333. Because either way, because repeated, you know, you trunk it and you maybe you lost approximation, you can write definitely like that, like that, like that, like that, or like that. Doesn't matter. I prefer like that because I found the complication. Okay, 3 is repeated. You trunk it, you put 63, you lost approximation. Maybe much better like that. Okay, so help me. Everyone working with the calculator, so the answer X approximate, 4 decimal place. You copy natural logarithm. So we practice a little bit natural logarithm, natural logarithm. Let me using another calculator, natural logarithm. Come on, guy, I waited for you. Natural logarithm of what? Natural logarithm of 0.51. Close the parenthesis. Division what? Another logarithm. And inside the logarithm, we have the several operations. We have 1.7 square, 1.7 square, divided by what? Divided by 0.3. And close the parenthesis and present. Boom, I get the answer. Pero you help me. Come on. You help me.
What do you want me to divide, Professor?
Divide by 1.7. So, and my displays, I type in like that. Look, this is my display. I type in ln, automatically the calculator put the first parenthesis as this. You put 0.51. Close the parenthesis because I ending the top part. Division by another logarithm. And you put 1.7 squared, so power 2. I don't know exactly when you calculate how. Divided by 0.3. And close the parenthesis and press enter. Yes or no?
I'm dividing it right now.
Mm-hmm. Come on, waiting for you.
Yeah, I got the answer. I posted in the chat.
Let me know what it is. Negative.
Sometimes it's wrong.
Very well. You are Michael, huh?
Yeah.
Okay, Michael. Michael do well. Well, it's negative 0.2970 what? 70 what? I erased the display. Help me. 229. Oh, let me see.
25,
25.
22, 7.
7.
Yeah, I posted in the chat. It's negative 0.297, 2522, and 699. 699.
699.
Mine is.
Okay, wait, remember, any calculator is different because any calculator is different device. And the approximation part, some calculator is more accuracy than another. But you don't worry because you don't need too much decimal place. You need 4 only. 1, 2, 3, 4. See, the next digit is 5 or greater than 5, you increase it. So my answer is negative 0.2973. Cool? Cool or no?
Yes.
Okay, that's it.
Yeah.
This is the thing that we're doing in the test. Okay, one more. Cool, Sophia. Okay, I suppose que no. Stop here because I need to travel to another camp, guys. So remember, today after the 5 p.m. I will send the review package plus the test number 4. You are doing something, no? The something that you don't know because we study not too much. We need to study another topic. It's the application, it's the most complicated part. But you are working something. You're working something. Okay, and maybe not for sure. Next Friday is the last day, and we dedicate the rest of the semester, it's only 1 week more, to the final test. Can remember, it's not mandatory. So you get A, in the 4th test. You don't need to you need to take, sorry, the final, because your overall grade is A. Only the student can make a mistake, fail one test, or need to improve. It's easy. You compute, you have 8 tests, no? 4 on paper and 4 online, and you compute the average. You adding everything that you have in the canvas. Okay? I appreciate so much that you checking my work. See, there are some discrepancies, you let me know, and we negotiate that. You addition, sum, every test, in total 8, divided by 8 is the average, no? And you get 85. And 85 B. And see, you feel good. B is good grade for me. Okay, no problem. You don't need to take the final. I guarantee 100%. Can you see in your final grade A, B? As you need to improve this B, you take the final. Suppose that you are doing the mess in the final because you don't remember anything. Your grade stays the same, B. Always I include in the formula the final grade if you improve. Okay? This is very, very, very hard to fail this class. Well, no, some people fail. A lot of people because they are too lazy. So you fail it because you are lazy. Okay? Okay, guys. Entonces, I gotta go. Thank you so much.
Thank you, Professor.
Next time, I want to see your
Thank you,
face.
Professor.
Next time, I want to see your face. I see the face of Savannah Crespo. Bye. The rest, no. I want to see Elsa face, Jasmine face, and the another two. I prefer to see the face of the woman, no? But it's okay. Bye-bye.